This is Lab 4, the mass spring system, two-dimensional motion. The tasks are to compare in the display window the predicted motion and the observed motion of the mass that we got from the tracker file, and also plot the energy changes, the total energy change, the kinetic energy, the change in gravitational potential energy, and the spring potential energy. And then we had to calculate both the x and the y periods from the motion data. Principles were used were the momentum principle, the energy principle, and Hooke's law. So this is the tracker analysis. We accumulated the data, we plotted both the X and the Y, and this is the data table, which was then exported out as a CSV file. From the tracker analysis, we came up with two different periods. This is the X period, 1.652 seconds. And this is the Y period, peak to peak, for several calculations, 1.52 seconds. The energy principle states that the total change in energy is equal to the sum of the change in the kinetic energy, the change in the potential spring energy, and the change in the potential gravitational energy. When the change in energy is zero, then the energy is conserved. That means there's no change in the energy of the system with the surroundings and with no external forces acting on the system. To find the spring constant, from our motion analysis, we were given the period, 1.52 seconds. We plug it into this, we do some rearranging, and we come up with a spring constant, Ks, of 6.87 newtons per meter, or kilograms per second squared. To find L naught, we're given the mass, we know G, and from the spring constant we just calculated above, we plug this in, do some rearranging, and come up with a value of 0.127 meters. Okay, the initial conditions, we were given G, we've calculated the spring constant. Here's the L naught, the relaxed length. The loop calculations, notice the spring mass data too. This is from the tracker, it's in a CSV file. And this is the calculation of the initial energy changes, Ke, the potential energy for both the spring and the gravitation. Loop calculations, as we go through the different iterations, these will update them. So we have the Ke, the gravitational, and the spring. Okay, this is the Python results. And what we see here is the total kinetic energy, which is the yellow line, is indeed zero. That means the sum of the gravitational potential energy, the potential energy of the spring, and the kinetic energy sum to be zero. The Python results for the predicted and observed motion, we have very good agreement with this. You can see the blue here, which is the predicted motion, and the red is from the tracker calculations. Okay, so the results, we predicted the motion from the Python program. It matched very closely the data from the tracker. We verified the energy principle. We successfully calculated both the X and the Y periods. And we found the spring constant and the relaxed length of the spring. So what's it mean? Well, yes, the energy principle as seen from the Python graph is satisfied. The sum total of the kinetic energy, the spring potential energy, and the gravitational energy equals zero. And what does it mean too? Based on the tracker information, we came up with two different periods. This could be due to measurement of human error measurements, but both periods should be the same.